Good morning, everyone. Let's begin. We're going to have class on Thursday back in the computer lab here, and we're also having a quiz on Thursday. So that should give you an idea that you might be using the computer for the quiz. The coverage is everything we've done since the last quiz, right? I guess, or did we have is this the first quiz since the exam? All right, so from the last quiz till this one, including today. Homework number 9, I've just given you the handout for that. That's going to be due on Sunday the 8th, and it includes the incremental analysis that we're doing today and the past lecture stuff. So let me know if you've got questions on that assignment. What we're going to be doing today is incremental internal rate of return analysis. And let's refresh our memory on the assumptions behind internal rate of return. Remember that when you calculate the internal rate of return, it's assuming that you take the revenue and you reinvest it in the project in order to have your earnings receive additional revenue at the same rate of return. So it's the same idea as compounding in a savings account. That's why it's called internal rate of return, is because you're taking the returns and putting them back into the project. The other thing to keep in mind about the internal rate of return is we've always said don't compare internal rates of return for projects. And let's look at another illustration of why. We did something like this in class last time. And what we saw, we agreed that if you're running a company, you want to maximize your profits. It's nice to have a high percentage return, but really what you want is not some abstract percentage. You want the most dollars or the most dirhams. And so we did a calculation that showed sometimes comparing IRRs alone would give you the wrong answer. Here are some different numbers that make the same point. What this is showing you is that alternative A and alternative B, of the two, alternative B has the highest present worth. But alternative A happens to have the interest rate that is the highest. And so what we want is we want the project. Hi, how are you? You want to have the project with the highest rate of return, but what you really want is the highest project with the most profits. So you should go with option B here. Now, the incremental rate of return, it shows that the difference in cost between B and A, it's an extra $13,000 that we have to pay, but we receive an extra $4,000 each year. And so, what do you think this 11.4% means? What's the interpretation of that? On what? All right, I can see why you'd think that, but if you look, project B on a percentage basis actually has a lower internal rate of return. So on a percentage basis, it doesn't look like it's making 11% more. The value of the profit. It turns out this 11.4 is saying that's the rate of return on the difference. So this extra 13,000, it's like the 13,000 additional that you have to pay to get item B, that 13,000 is making a return of 11.4%. And so the reason why we say yes to project B is that the rate of return on the difference is greater than the MAR. So our MAR is 10%. That's saying maybe we had to borrow money from the bank to finance these projects. If you're borrowing money from the bank at 10%, but you can get 11.4% on the project, then you should do the project because you're making more than the MAR. So the incremental internal rate of return of 11.4% is how we know that option B is better. There's more than one way to know which choice is best. We could already know which choice is best just by looking at the present worths. But maybe your boss wants to know not only what is best, but how much additional return do we get on option B? And so you'd have to do the incremental internal rate of return to know, what's the value of the additional investment on a percentage basis. Yes?
So if the incremental rate of return is less than more, that means it's still
if it's less than the MAR?
Yeah.
Yeah. So let's say if it was 9%, that means that there's a positive rate of return on the investment, but if our MAR is 10%, that rate of return isn't high enough for us to say yes to the additional investment.
So we go with the lower profit?
We would go, well, it wouldn't be lower profit. It would be the alternative that has the highest profit when discounted at the MAR. So in the example, what you were saying, where maybe this was 9%, then that would have, option A would have showed up as our best option anyway. You'll never get a conflict between present worth analysis and incremental internal rate of return analysis. They'll always tell you the same answer in terms of which one's best. Yes? There will never be a case where that'll never happen. It'll never happen. The present worth will always give you the same answer as the incremental internal rate of return analysis. So you'll never have a situation where maybe it's said A in the present worth analysis, but then you got the incremental internal rate of return of the difference greater than the MAR. That'll never happen. We've got a nice lengthy example today that'll illustrate when to accept and when to reject. Our criteria that we're using when you're doing the incremental analysis is if the internal rate of return of the difference is greater than the MAR, then you should go ahead with the additional investment. It's justified.
Why do you go from
Because we want to find out the difference in cost. And so B minus A says there's an additional $13,000 in outflow, and the additional inflow each year is $4,225. So that's why we do B minus A and not A minus B. Is the way that the negative sign means outflow, and so the extra outflow of B compared to A. Here's an illustration of what you're going to do today. And it'll really help you do today's in-class exercise correctly if you understand the logic behind this. And so I'm going to talk through what the interpretation of this analysis is. What you can see, first of all, is that these columns are in order. And by the way, don't start on today's in-class exercise already, because the numbers on the handout I gave you are wrong. So I think maybe some of you are already jumping ahead on the spreadsheet. You're actually shooting yourself in the foot because the numbers aren't right. All right. So I'll tell you the correct numbers in just a minute. Let's focus on the procedure, because I don't want to get the same questions of what I just told you from the procedure in a minute because you jumped ahead. So put them in order in terms of the cheapest to most expensive. You can see option A is the lowest cost. It's $38,000. Option B is $50,000, and so on. In the incremental analysis, what you do is you compare the cheapest option to the next most expensive. So we're comparing B and A in this column. So you'll see the difference in cost is $12,000 and the difference in revenue is $3,100 for each year. The internal rate of return for the increment, so delta IRR, just means calculate the internal rate of return on this column. So the formula is equals IRR, and then you just highlight the cells. It's a very easy formula. It'll tell you the rate of return on the additional investment of $12,000. Our criteria is compare this 22% to the MAR. And in this illustration that's on the screen, it says the MAR is 18%. And so the finding is that this internal rate of return is greater than the MAR. And so our interpretation is yes, do B. B is our new champion. That's the alternative that we like best. And so the next thing we're going to do is we're going to compare option C to option B. And we're going to find out if this option C, which is more expensive, is worth it. Is that extra amount, is the extra $5,000 for option C worthy investment? And so we do the same thing. We calculate the internal rate of return. We find it's 43% for the increment. And the finding is that's greater than the MAR. And so now, yes, we should do C instead of option B. So option C becomes our new champion. And we have to compare the next alternative, alternative D, to option C. When we find the internal rate of return on the increment, the rate of return is 0. 0 is less than our MAR. And so the finding there is that, no, we shouldn't do option D. We're going to stick with our old favorite of option C. And so the next comparison isn't E minus D. We don't do E minus D because we've already rejected D. What we're going to do is compare E and C, since option C was the last one that we said yes to. And so you can see the final column is E minus C. And so we want to find out, is that extra $15,000 for option C worthwhile based on the additional revenue that it generates? We find the internal rate of return on the difference is 14%, which is too low. It's lower than our MAR of 18%. And so the answer is no. We don't do option E. And from our final conclusion, we see that option C was the last option that we said yes to. And so that's the best alternative. Because in this column we rejected D. We said D isn't justified. And so in our mind, the last project that was justified is option C. And so now we have some new challenger. This last project here, project E, we don't know if it's good or not, but the last one that was good was project C. And so we compare it to our current favorite. So what's the best option? What's the second best option? Right. So the last project that you say yes to is the best option, and the one before that you were still saying yes to until you found your new favorite, that's the second best alternative. Yeah. Yes. Yeah. So if A was good, but we rejected B, then your next analysis C, then you do C minus A. Exactly right. And you'll have to remember that for today's in-class exercise. I changed the numbers around a little bit because I wanted to have you go through the process of finding a good one and then rejecting the next one and so on. So these are actually the numbers. If you'd please update what's written on the paper there to the numbers that are on screen for the in-class exercise. I can bring it up on the projector. I made some changes in the solution, but I forgot to update the handout I gave you. So Caterpillar is $47,700, and these are investments. A capital investment means that's an outflow. Komatsu is cheaper than I had written on the page. Komatsu should be $22,500. Volvo stays the same for the cost, but not the revenue. So update the numbers. Okay, so today's in-class exercise is a step-by-step thing. What you're going to begin with is the idea that there's several alternatives available, and this is for highway construction equipment. We have to borrow money from the bank to finance the equipment. The company has set a MAR of 12% because that's how much it costs them to raise the money for the equipment. And so what we're trying to find out is which of these alternatives is best. Now, we already know the easiest way to find the best alternative is just find the present worth discounted at the MAR. Well, I ask you to do that at the end to double check, but let's use incremental analysis to find which alternative is best. And it tells us not only which is best, but it also tells us the rate of return on the increment, which is an important thing to know. So what you're going to do in part A is find the internal rate of return of each of the alternatives. Not yet of the increment, but of the alternative themselves. And if any of them have an internal rate of return less than the MAR, then you reject those options. And there's going to be one that you can just reject from the very beginning because you'll find the internal rate of return is less than the MAR. And then in part B, I give you the hint that you should start ordering them in terms of cheapest to most expensive. So go ahead and get started on the in-class exercise. I've got the solution, and I'll be circulating around with that if you want to check your answers. All right, the first thing that we did, I wish that projector was larger, but if it's too small, at least you've got the video. The first thing we did, our MAR is 12%, and this is the data as it was given, or kind of as it was given, as I corrected it for you. What we want to do is find out the internal rate of return for each of them. This one, 8.9%, is below the MAR. And so the first thing we can do is reject Komatsu. It's out of the running. It's not one that we're going to accept. So when we do the incremental analysis, we want to sort them from cheapest to most expensive. And the reason why is always go with the cheapest option unless there's some reason to spend the extra money. And that's what we're finding in this analysis is there any reason to spend the extra money? So we're going to start with the cheapest and then look at each additional cost to find out if it's justified. So in order of increasing amount, we go Deere, Caterpillar, Hitachi, Volvo, then Atlas. I've abbreviated them by the name of the company here. So my first comparison is going to be Caterpillar versus Deere. And so the extra amount is $25,700. That's how much more we have to pay to get the Caterpillar than compared to the Deere. The $4,400 is the extra revenue you get for that each year for the investment. The incremental internal rate of return, so this IRR on the difference is 11%. That's not good enough. We have to have a return of 12%, and so what the interpretation is no, the extra cost is not justified, and so we're going to reject C, and D is our favorite. So Deere, which was the cheapest alternative, that's our champion. That's the one to beat from now on. So our next comparison, the next thing is Hitachi. So we're comparing Hitachi to Deere, and it's an extra $33,000 to buy the Hitachi equipment. But the nice thing is it generates an extra $7,500 every year. So we can calculate the internal rate of return on the increment and find that it's 19%. That's greater than our MAR of 14%. And so the interpretation is yes, the extra cost is justified. Conclusion, Hitachi is our new favorite. So our best option so far is Hitachi. What's the second best option? Deere. Right. So Deere was the last thing we said yes to before we switched to Hitachi. All right. So let's take a look at, oops, I jumped. All right. Let's take a look at Volvo minus Hitachi, Volvo versus Hitachi. So the added cost versus the added revenue. What does a negative internal rate of return mean? Well, if you look at it, the total inflows over the 10 years is only going to be $7,000. And it costs $15,000. So even before you consider the time value of money, it's obvious that the Volvo is a terrible investment. So the negative IRR tells you the same thing, that you're not even getting your money back, much less additional profit on top of it. So the extra cost, no, is not justified. Conclusion, keep Hitachi. So our last comparison is Atlas versus Hitachi. There's an extra amount, extra revenue. At least this time the incremental internal rate of return isn't negative. At least this time it's a positive. But still 7% isn't enough because our minimum is 12%. And so the extra cost, no, is not justified. Our conclusion, H is the best alternative. So on the handout it's asking you what's the internal rate of return on the increment between the best option and the second best option. This is what you should write. It's the 19, or if you're going to have additional decimals there, 18.6%. So what do we know through this whole analysis? We know that Hitachi is best, but we also know that you can make 18.6% return on the $33,000 that it costs over and above the Deere. In Part D, I asked you to confirm your conclusion using present worth analysis. So here are the original values again, and I found the present worth. I have here present worth. I suggested that you use the NPV function. The NPV function, you only apply it to things in the future. So let me show you that. Equals NPV. at the interest rate that we have of 12%, and our range of values is year 1 through year 10. And then what I have to do is I have to also manually add in the amount that's already in the present. And so it's not just the NPV function here, it's the NPV plus what's already at the present. And so the best present worth here is the Hitachi. So that's the easy way to find out what's best. You know, it's easier just to find the present worth, but going through the incremental analysis tells you why Hitachi is better than Deere. Hitachi is better than Deere because that extra amount you have to spend, the extra $33,000, it returns a yield of 18.6%. And since that's greater than the MAR, always spend as much as possible as long as that additional amount is justified. The other way of looking at it is always spend as little as possible unless the additional amount is justified. All right, any final questions on the in-class exercise? Yes?
Can you just show her the NPV again?
Yes. The NPV, it'll take future values to the present. So equals NPV at our MAR, the rate of 12%. You highlight all of these values that are in the future already, and then you have to manually add in this year 0 amount because it's already in the present. The year 0 amount is not included in the NPV function because it's not in the future. So then you press enter on that. Reminder, we're going to be back in here on Thursday. You'll be taking quiz number 4, which the coverage is from our last quiz until today's lecture. And please remember to write your name on the in-class exercise and set it on the chair on your way out. Have a great day. See you on Thursday.